Hello. Today I'm going to discuss section 3.3, division of polynomials. We're going to learn today the objectives of this section, how to do the divide a polynomial using the long division, synthetic division. We're going to also learn about two theorems, the remainder theorem and the factor theorem. And then we use them to evaluate the functions. Furthermore, we're going to use them in the following section and find the rational functions, and it helps us to work with rational functions. So let's start here. I'm going to share the screen. All right. And okay. So the first thing I have, let's get a motivating example first. If I say that let's say 157 divided by 7. So this is a long division. So I divide 15 by 7, I'll get 2. And 2 times 7 is 14. Subtract 14 out of 15, I would get 1. And then 1 cannot be divisible by 7, so I get the 7 down here. So 17 divided by 7 is 2. 2 times 7 is 14 again. And 14 out of 17 is 3. So now, what I got here, that 22 is, excuse me, that 157 is 7 times 22 plus 3. So now I'm going to call this the factor. 7 is the factor, and the 3 is the remainder. So this is the simple example how to show it through regular arithmetic. Let's make this a better idea in polynomials. So if I ask you to do x squared plus 3x minus 7 divided by x plus 2. The idea here is more steps. Same idea, but it's more steps. So I write the polynomial here, 3x minus 7. And here is the divisible, or divisor, sorry. I now check, is x squared plus 3x minus 7 divisible by x plus 2? If I get remainder 0, then it is divisible by x plus 2. If not, I should get a remainder that is not 0. Okay, let's see. So I started by x squared. X squared divided by x is x. X times x is x squared. And x times 2 is 2x. Okay, and subtract x squared plus 2x from x squared plus 3x. So I get here 0, and then I'd like to change the sign, make this negative, and then add. So basically, this is canceled out, and here is 3 minus 2 is 1, so I get x, and then minus 7. So x minus 7 divided by x plus 2, so x is 1, so plus 1. 1 times x is x, and 1 times 2 is 2. Okay, subtract, change the sign, and then add. So x minus x is 0. And -7, -2 is -9. So now I have the remainder is -9. So now I can write the polynomial x squared plus 3x minus 7 is the same thing that I did here, x plus 1 in the first example, times x plus 2, the divisor, and plus the remainder. I'm sorry, it's a minus. Actually, it's a plus, but the remainder is minus 9, -9. Okay? All right. So let's get something easier than the long division. We call this the synthetic division. The idea of the synthetic division is to find the zero of this divisor. So if I say x plus 2 here, the divisor of x plus 2 is -2, because -2 plus 2 gives me 0. Okay? So the divisor here, let's make this in red. Here's 0, 0, here's a 0. 0 is -2. All right, let's see how we do that in a synthetic division. I'm going to get the same thing. Okay, so again, I'm dividing x squared plus 3x minus 7 by x plus 2. Okay, so I am going to take the coefficient of the polynomial here. I'm going to take the coefficient of these, which is 1, 3, and -7. And here, the zeros, and as I said, that the 0 is -2. Okay, I'm going to do letter L, like that. It's not letter L, but it's close to. Okay, and write the 0 here. So the 0 is -2. And then write the coefficients here. Make sure that if you have a coefficient of a variable that is not there, for example, if I don't have 3x, you can't have the coefficient 1 and -7. You have to put 0 here if you don't have any coefficient of x. Okay, we're going to see that in another example. All right, so I have the coefficient of x squared is 1, the 3x coefficient 3, and -7. We start, the first thing is to get this one down here. I get 1, multiply 1 by -2, and I get the answer here. So the answer is -2. Then I add 3 and -2 and get the answer here. So I get here 1. Okay, I'm going to do the same thing. I multiply 1 by -2 and I get the answer here. So 1 times the -2 is -2. And then I add -7 and -2, I'll get -9. So this, the last one is the remainder. So if you look here in the long division and the synthetic division, the remainder is the same. So now let's write what is left. How can I write that as the divisor, or as the out of the division here? So actually, when I look at this is the constant, that would be, this is the constant, and that would be the value or the coefficient of x. So that means that I have x here because the coefficient is 1, and the constant must be 1. Notice something, when I divide the second degree here by the first degree, there must be, the quotient must be a first degree as well. Because when you multiply back x times x, you get x squared. Okay, so if this x cubed and I divide by x plus 1, that the quotient out of the division must be x squared. All right, let's get another example by synthetic division. All right, I have x cubed, and now there is x cubed, minus 7x squared, plus 3x, or minus 3x, minus 3x plus 4 divided by x minus 5. Okay, so let's do the first thing. I have a coefficient 1 for x cubed, and negative 7 for x squared, negative 3 for x, and 4. And the 0 here is 5. So now everything is clear to perform the synthetic division. Put the 0 on the left, which is 5. The coefficient 1, negative 7, negative 3, and 4. Now we get the 1 down. So I have 1 here. And 1 times 5 is 5 here. 5 minus 7 is negative 2. Negative 2 times 5 is negative 10. Negative 10 and negative 3 is negative 13. Negative 13 times 5 is negative 65. Plus 4, I got negative 61. So now the remainder is negative 61. So this is the remainder. I'm going to call it R. And the out of the division is 1. Here is x squared. This is the constant. This is x, and this is x squared. So I write here 1x squared minus, let's write this x, 2x minus 13. So this is the out of the division. Okay. All right. I hope that this is clear. Now, let's think about something. I have f of x, if f of x which is a polynomial, is divided by x minus c. Then the remainder is f of c. What does it mean? So let's go for the last example here. So here is my polynomial, and this is x minus c here. So just suppose that this is f of x, and this is x minus c. If you plug c, which is 5, this is a 0. Okay, c is a 0. So if you plug c here, or the 5 here, you must get a negative 61. Let's try that. So based on this theorem, we call this the remainder theorem, that f of c must be R. Let's try that. So based on the last example, I'm going to write it down here. F of x equal x cubed minus 7 x squared minus 3x plus 4. Okay, so now my 0, the one that I talked about, is 5. So f of 5 equals 5 cubed minus 7, 5 squared, minus 3 times 5 plus 4. Let's evaluate that. 5 cubed is 125, minus 5 squared is 25, times 7 is 175, minus 3 times 5 is 15 plus 4. Okay, 175 negative and 125 positive, so that gives me negative 50, and negative 15 is negative 65, plus 4 is negative 61. So this is negative 61, this is negative 61, is the same as the remainder that I got from the synthetic division. And it is also the same that the one that I got from if you do the long division. Okay, so let's get another example. I'm going to use the factor theorem. So I give you the factor, or it's not a factor, it's divisible, because if the factor, the remainder must be 0. So the divisor, I'm going to give you the divisor. You give me the 0, you plug the 0, f of the 0, and then we get the remainder. Okay, so let's get that example. I have f of x equal x to the 4th minus 2x cubed plus 5x squared minus 8x plus 9. And I want to use, here I'm given f of 3. I want to make sure that the remainder when I do f of 3. So I'll start first and do it with the synthetic division. So if I do the 0 is 3 here, 0 is 3. If I use the synthetic division, 3 is 0. The coefficient 1, negative 2, 5, negative 8, and 9. Let's do the synthetic division and get 1 down. So 1 times 3 is 3, is, excuse me, 3. 3 minus 2 is 1. 1 times 3 is 3. I got 8 here. 8 times 3 is 24. 24 minus 8 is 16. 16 times 3 is 48. And 48 plus 9 is 57. So the remainder, what I got here, is 57. Let's try f of 3. What should I get with f of 3? Because this is a 0. So f of 3 is 3 to the 4th minus 2 times 3 cubed plus 5, 3 squared, minus 8 times 3 plus 9. So 3 to the 4th is 81. 3 cubed is 27 times 2 is 54. Plus 3 squared is 9. 9 times 5 is 45. 8 times 3 is 24. So negative 24 plus 9. Okay? Okay, let's evaluate that. So if evaluated, 81 minus 54, so that should be 57. If you try that, if you add it using calculator, you're going to get 57. Oh, so this is the same number. Both are the same. So what I can conclude from here is that the remainder theorem helps me to evaluate the remainder. It doesn't help me to get the out of the division. No, it doesn't help me to get the out of division. However, if you need only the remainder, okay, you use the remainder theorem. Just plug the 0, f of the 0 gives you the remainder, okay? All right, let's get another theorem. This theorem, I'm gonna call it the factor theorem. All right. So, based on the remainder theorem, okay, what happened is this is a result of the remainder theorem. So, the remainder theorem said that if you have a 0, x minus c, okay, if you divide a polynomial, f of x, by x minus c, then f of c, okay, equals r, the remainder. Okay, here's a question. What if I get the remainder 0? If you get r, this is 0. That means that there is no remainder. Therefore, x minus c is a divisor of f of x. So here is the theorem. Said that if f of c equals 0, meaning that the remainder is 0, okay? Therefore, x, that means that x minus c is a factor. Okay? Let's get an example, an easy example to evaluate, to understand this one. But this one goes two ways. So if f of c is 0, then x minus c is a factor. Again, let's get it backward. If x minus c is a factor, then f of what? F of c equals 0. So it goes both ways. Okay? All right, let's get a simple example. If I take f of x equals x squared minus 4. This is an easy example because we can factor x squared minus 4. So here f of x equals x minus 2 times x plus 2. Okay? So I'm going to take, now how many factors do I have here? I have 1 and I have 2. Okay, so here's what is the 0 here. I know that x minus 2 is a factor of x squared minus 4. So if I take 0, here's the 0 is 2. The 0 equal 2. Based on that theorem, f of 2 must be 0. F of 2 must be 0 because x minus c, or here is x minus 2, is a factor. Let's try that. F of 2, my 0, I'm going to apply that here. So we expect to get 0 equals 2 squared minus 4. But this is equal 4 minus 4 equals 0. So do you understand the theorem? And if you take it backward, if you get f of a number, a certain number that is 0, that means that x minus that number is a factor of the polynomial. All right, so let's get an example here, and then get 2 examples, and then I'm going to stop by that. All right, so let's take, if we need to check So here's an example. I need to check if x plus 3 is a factor of x cubed plus x squared minus 11x minus 15. Okay, by factor theorem, f of c, but c here is f minus x minus c. So c here, c is how much? Negative 3. Don't say 3, it's a negative 3. So here c is negative 3. So f of negative 3 equal negative 3 cubed plus negative 3 squared minus 11 times negative 3 minus 15. Okay, so negative 3 cubed is negative 27. And negative 3 squared is 9, so plus 9. Plus, my negative times a negative is plus. 3 times 11 is 33, minus 15. Okay, so here is negative 27 plus 9. That would be negative 18. And negative 18 plus 33 is 15. 15 minus 15 is 0. Cool. Therefore, I got f of negative 3 is 0. What can I conclude about that? That x minus c, or x plus 3 here is a factor. So thus here, x plus 3 is a factor of x cubed plus x squared minus 11x minus 15. Okay, I hope that this is clear. Let's get one more example. I'm getting this example because it has, I'm going to use two things here. It has a different idea. So I'm given that x cubed minus 7x plus 6 equals 0. And I'm giving you that x minus 2 is a factor already, is a factor. So I know that x minus 2 is a factor. I'm asking you to solve this equation. Solve this equation. Okay. So in this way, I am using the synthetic division. I have the 0. What is the 0 here? What is the 0 here? The 0 here, yes, it is 2. So the 0 equal 2. So I'm gonna use divide this polynomial by the synthetic division with the 0, 2, and get something must be quadratic because I'm dividing by the first degree. Okay, let's do that. Let's check the coefficient first. I have here coefficient 1 for x cubed. But how about x squared? I don't have x squared. So in this case, I put 0 in x squared. And I have negative 7 for x, and then for constant, I have 6. And the 0 is 2. So let's plug the 0 first. And then I have 1 for x cubed, 0 for x squared, negative 7 for x, and 6 for the constant. Get the 1 down. 1 times 2 is 2. 2 plus 0 is 2. 2 times 2 is 4. Before I continue, what the remainder do you think we get? Yes, I should get a 0 because I'm given already that 2 is a 0. So let's see. I must get 0. Okay, -7 plus 4 is -3. -3 times 2 is -6, and I got 0. And it is expected. So now, out of the division, I have, this is -3 constant, 2 times x and 1 times x squared. So I got x squared plus 2x minus 3. And this is equal 0. So now I have to factor this. And this is a straightforward quadratic equation. So -3, I have to find two numbers. Their product is -3 and their sum is 2. I have x and x, that must be obviously 3 and -1. Okay, so now the zeros of that polynomial are I have 2, and here I have, that gives me that x equal -3, and here is x is 1. So now I can factor x cubed minus 7x plus 6 equal, here's x minus 2 first, times x plus 3 times x minus 1. And I hope that this is helpful for you, and see you in the next time with the rational function. Okay, thank you so much. Okay.